tonight I'm doing the presentation, and it's episode 57, which every time I say that, all I can think of is Heinz Ketchup, which is pretty funny. And we had great people come in, and we have a lot of people here tonight. A lot of people registered, and they have no idea what tonight we're presenting. I did let one person know because it was actually his idea when we put that whole competition together. So tonight we're doing Snowmelt. So some of these pictures are mine. Some might just scarfed off the web off of people that are out there. If this is one of your jobs, thank you very much for putting your pictures out there on the internet. So tonight is a primer on Snowmelt. By primer on Snowmelt, this is to give you the 10,000-foot view of what Ted and I, both as sales managers for two different rating companies, have dealt with for a long time. Ted and I have been doing Snowmelt and rating heat since the 80s. In fact, that's how Ted and I actually met, was through the rating industry. So which is pretty cool. We're definitely not a PEX tube company. Ted and I used to work for him, but we no longer have a PEX tube company. This is not to replace any of their Snowmelt training. I suggest that you go to any of your manufacturer's Snowmelt training when it becomes available. Tonight's guide of what you can and should do is based on our experience. I'm sure Ted will be chiming in while I show some of these slides. Some of these are ancient, some of them are new, and Ted will greatly appreciate some of the stuff that I've pulled out of some of the books that were available back when we first got into this stuff.
Hey, you know my feeling on this. When you guys came up with this topic, I said you and Ted are two perfect guys to do it.
I want to make one thing clear. There's no such thing as a cheap Snowmelt job, period. This is no place to create a cheapism. You might be able to get away with being cheap when you do a bathroom. You might, with rating heat, you might be able to get away being cheap doing a basement, but you cannot be cheap when doing a Snowmelt. Make that clear and understood that you cannot do that. So let's look at how we have to start, right? So here we got the nice little snow that we have out west. Snowmelt must be designed. There's no question on that. Must be designed. Use a program like Wrightsoft, which I love. Use an engineer who can do it for you. Use your local manufacturer's reps who have been authorized by the tubing company that they represent to do Snowmelt designs. Use your tubing manufacturer if your rep is incapable. Every tubing manufacturer out there has a designer in-house that can do your Snowmelt. And you're going to need the following information we're going to go over. I want to go back here for 1 second to a phone call I got 3 weeks ago from a guy who said, "Hey, I got 12 zones of Snowmelt. What size circulator do I need?" I have no clue. He had his boiler circulator and the circulator on the system pointed opposite directions of where they should go. He didn't have glycol in the system, and then when he put glycol in the system, he put 100% glycol in the system. There's things we're going to go over tonight of what not to do, Once you're in concrete, once you're under a slab, once you're under pavers, you're paying a lot of money to go out there and tear all that up and do this shit again. So listen to what we have to go over tonight, please. So how to start? Find out what your customer wants. What are their expectations? What is he looking for? What do they need? Do they want to melt the snow in 24 hours? Do they want to melt the snow while it's falling or within a couple hours? Or do they want to melt and dry it while it's falling? And yes, these are 3 levels of ASHRAE standards that are written in the code books, folks. Snow melt in 24 hours. That would be a Class A residential snow melt. That's only 60 BTUs a square foot that you figure on. And that's based on when there's snow on top. If there's no insulation on top of your slab or your driveway or your snow melt period, it's giving up over 250 BTUs a square foot trying to heat the stars out in the universe. So please, if there's no snow, you're going to puke heat. Trust me on this. This is usually sufficient for Joe homeowner. And let me explain Joe homeowner, because he's not your 10%er. And if you're going into a place where they're doing the courtyard so that people can come in their Jaguars and turn around and get the heck out and get off the guy's property without slipping and falling so he doesn't have any liability, then you do not want to do this. You want to go to melting snow while it's falling. This is ASHRAE type 2, light commercial. It's 125 BTUs a square foot, almost a little bit more than twice the amount. Again, only when there's snow on top, as we talked about. This is usually for churches and businesses and people who have a ton of money who want to take away the liability of their system, right? The nice thing about doing this in front of a church or a business is no longer do they have that big salt stain walking into their narthex or into their lobby or across the hardware store floor. There's no more of that. There's no more salt. And there's no more lawsuits from people falling on your walkway to get in if it's installed and working correctly. So, melt and dry it. This is ASHRAE Class C, commercial snow melt. This is 250 BTUs a square foot, usually in situations like helipads on top of hospitals, because this has to melt and dry it as it's coming down. Ted and I have both seen pictures that of the downdraft that comes from the propellers on top of a helicopter forces the snow to freeze if you have water on top of a cold surface. You cannot afford that. Back in the late 90s, early 2000s, I had a picture, I couldn't find it there, unfortunately, of a Sikorsky ambulance helicopter sliding off of a snowmelt roof, because as he was coming down, what looked like it was melted and what everybody was walking on became sheer ice from the blade wash. And they all took the body out, or the person out of the ambulance, and they're rolling it up the ramp to go in the hospital, and looked over their shoulder, and here goes their quadrillion $1 million Sikorsky sliding off the roof and falling 3 stories to the earth. This is not a call you want to make to your boss as the helicopter pilot, but it's also not the call you want to get as the contractor who put this in and it didn't work, to find out that you're buying a helicopter. So
also, when these guys are running out of the hospital with that gurney to try to get the guy off the medevac helicopter, the last thing we want them doing is slipping and sliding around on that deck as well.
Exactly. So you need to find out what. I'm sorry, Jason. What did you just say?
Have you ever been in a helicopter?
Yeah, I have.
Oh, hell yeah. I was in one in Hawaii, man. It was nice. We flew over where they did King Kong. It was nice. It was one of them bubble ones.
Anyway, so
I had to tell you that. I just thought about it.
Anyway, so I can tell you that the blade wash from a helicopter is not something you want to be standing in a field feeling. I can tell you that because I have put people in medical helicopters. So anyway, step 2 in the type of snow melt area. So now we know what the customer expects, what they're looking for as far as how many BTUs we're going to spend, right? What you're going to need for heat. So we need to know the area use. We need to know whether it's a driveway, whether it's a walkway, whether it's steps. We need to know, will it be concrete? Will it be pavers? Will it be pavement? Will it be grass? What are they trying to do? What are they trying to melt? Because without this information, nobody can design this thing. So you need to have drawings of the snow melt area. This is pertinent because this is going to represent where you can possibly put manifolds to be able to get away with or be able to use the loop lengths that you can attain. You might not be able to have the manifold next to the house or in the house. You might have to have a couple of manifolds out along the driveway. Ted and I have both done this in sprinkler boxes, putting commercial manifolds out there with 12 loops, and they're 2-inch manifolds with 1 inch and 3/4 inch tubing coming off it. Trust me, there's a lot to go into this. In all types of snow melt, you have to get rid of the water runoff, folks. If you don't, it's just going to hit the pile of snow at the end of the driveway or at the edge of the driveway and create ice, and you're going to have a giant glacier. This isn't good. And for God's sake, and I know people do it, don't run the tubing just in 2 tracks where you think the gosh darn car is going to drive up it. This is bullshit. Either you're going to get snow melt or you're not getting snow melt. But those 2 tracks create nothing but ice dams to either side of them. And now it's great. You can stay between the tracks, but don't try to drive out of your driveway. So please do it.
Yeah,
so here's some,
actually, of all the things you just talked about, that's one of the things, unfortunately, that gets overlooked the most often, is what to do with that melt water. And all too often, I've seen an ice dam at the end of a driveway, so your driveway's all clear, but you can't get in because you got a glacier at the end.
A giant 8-inch curb you got to jump over of ice. Oh, we've all seen it, Teddy. Absolutely. So here's an old drawing I got out of a book that I did. A friend of mine, Jan Anderson, actually drew this up for Weersbo back in the 90s. So this is the different ways that we can install tubing. So let me bring my cursor over here. So you have concrete, you have tubing in gravel many inches below the asphalt. I want to make this clear. You cannot have tubing in asphalt. I can tell you firsthand that there was a manufacturer who's telling you could put the tubing in asphalt if you had umpteen amount of gallons of water going through said asphalt. And I can tell you, we had to tear one of these driveways up and we cut the tubing in half. And there was parts of that tubing that were less than a 32nd of an inch thick from that asphalt melting through. And we used what they consider a cold asphalt, which is only 640 degrees instead of 850 degrees. So it doesn't work, folks. It has to be down below to where it stays cool, and you have to run water through it while they're putting the asphalt over top. So this middle one here that I'm showing does not happen. Does not happen. Do not even think it. You will not find that in the book anymore. Then, of course, you have over here, you have bricks or pavers over stone dust or over concrete, mortar to concrete, with the tubing either in the concrete or the stone dust. The problem with stone dust is, one, it's sharp, but two, there's a long makeup time on that because it really doesn't start transferring the heat directly to the stone dust until it gets wet, and then the water transfers the heat up to the bricks or the pavers. I just was involved in a very large commercial job in front of a governmental building that was all done in 4x4 granite pavers. And Ted knows what I mean, the big 4x4 shiny granite pavers. And they're doing snowmelt because someone was walking in, and because they were put on sand and from the frost heaves up in the north, one of those pavers had come up and somebody tripped over, broke their leg, and sued the government, and of course got their money. So what we did, or what I designed and what the engineer put out there, was they removed all of the granite very carefully. They tore up all that sand. They put down stone. They put down tubing. They put the tubing in concrete, and then they mortared down the granite block so it could no longer move. So it had a very strong substrate below it. In this situation, if you're going over
to that way.
What's that, Ted?
I said it's better heat transfer too that way.
Absolutely, absolutely. Yeah. And you get no frost heaves removed.
I just want to talk about sand for 1 second, because I hear sand lots of times. Sand is actually a very lousy heat transfer medium. Sand it's basically millions and millions of little rocks with air in between it. Sand is an insulator. And if you don't believe me, go to the beach on a scorching hot day and try to walk. You'll burn your feet, but if you wiggle your toes, it's cold. So literally right below the surface can be too hot to walk on, but right below the surface, it's cold. It's not a good heat transfer medium.
God, Ted, that's a great analogy. And then just to finish this page, all the way up to the right is turf conditioning, which they were actually, there's a couple of golf courses that are doing snow melt on their greens and tee boxes, meaning you can't find your ball if you don't hit the green, and doing snow melt on it. But this does require additional controls that we're not going to discuss tonight. Ted and I have both been involved with the NFL on doing NFL stadiums to do turf conditioning so you can grow grass so that the people watching TV see green. We know people who have cut their grass in February and March in the dead of winter in the coldest regions of this country with turf conditioning. But there are a lot of things like maintaining good hydration and have hydration monitors in the grass so you know what you have. So please note that turf conditioning is possible, but tonight's not that night.
Yeah, that's a specialty field for sure.
Yeah. You know, the NFL has a standard on that, and it's all written up, and you can't break that standard. And that's all written by NFL engineers, and there's only 2 of those. So Anyway, here's just a blow up of tubing in concrete, probably my most favorite way to do it, because that way you can put anything on top of it. You can do colored concrete, you can do acid washed concrete, you can do a stamped concrete, you can put pavers over top of it, and it gives you a very strong base that can keep the tubing from moving and give you great transfer to whatever you're putting on it, right? So then of course you have the asphalt with the sand fill, which Ted and I both hate the sand fill. With the tubing down below. I'm not a fan of this. I try to talk everybody out of wanting to do asphalt with Snowmelt that I possibly can, because I don't feel it's a good way to go. You can do it. I know people who have done it. I have many jobs in cities where they've paved over it, but they're doing a lot of stuff to get to it. So brick and pavers, we already talked about this a little bit. And of course, back to turf conditioning. So, and I just wanted to show this little cutaway of steps, because steps are a good way to do it, but you have to make sure you melt those steps to the edge, because if you don't, people are going to slip and fall, and it's not going to be pretty. So anyway, a note on insulation. I used to tell everybody to insulate the entire slab and the edges so that all the heat goes up and nothing goes down. And I now call bullshit on myself. Yes, I call bullshit on myself, because I've learned a lot. Please insulate the edges. I was in a $10 million home where we did the courtyard. They brought in a 60-foot tall tree to put in the middle of the courtyard. They bought a 60 to 80-foot tall tree and put it in the courtyard. The problem is, if you don't insulate 4 feet down around the outer edge of that snow melt, the heat will get down to the roots, and that tree will be growing in the middle of March when it's not supposed to be growing until May, and you're going to kill the tree. So you have to make sure you insulate the edges.
Unless
Also
you
prevent growing grass.
a tree that's not native to the climate.
Yes.
If you're going to eat it, you could plant a tree that's designed for like Georgia or something, you know, where it doesn't typically freeze.
And then you got to keep your snow metal all the time, just to grow the tree. So anyway, don't insulate your horizontal areas. And I'm going to give you this scenario. It gets cold out at night. We get a nice misty haze. We get dew on the ground, right? But the surface temperature or the dirt underneath the grass is keeping it from freezing. But you have insulated your walkway, which got cold overnight and dropped below freezing. And now it's a fine sheet of ice, because no longer can the ground temperature get there. Now you've made an ice rink that people are going to slip on, because your snow melt control cannot feel the moisture and cannot feel that it needs to turn on, and you're screwed. You're going to cause big problems. This isn't just walkways. This is driveways. This is concrete pads. This is helipads. This is all of it. Do not insulate below, unless, of course, the engineer tells you to do it, and then it's on his liability, right? But for me, I no longer insulate horizontally for snow melt. Vertically 4 feet, yes. Horizontally, no. So just take that to mind.
I might offer one exception to that, Steve, if you don't mind.
Sure, Ted.
In that category 3 system, that's the one where you want it clean and dry all the time. Insulating it underneath, because you're going to have the heat on virtually all the time, is not a problem.
Yep.
But understand that you're, you know, like Steve said earlier, you're also putting 250 BTUs or more per square foot constantly. So that's a pretty hefty system to operate.
You need a lot of NTI boilers for that, just so you know. So ask Dave Yates, he knows firsthand.
That's a good thing.
So
That's a good thing.
a note about fluid. Use polypropylene glycol. That's probably spelled wrong. No less than 20% or it becomes unstable. And in my humble opinion, no more than 40%, because that will give you down to -60 burst protection. I aim in my area in Pennsylvania for about 25%, and I still have guys putting 50% in. And to that, your pumps are going because they think it's molasses compared to water, and it's horrible heat transfer. Not only is it thicker, but it doesn't carry or transfer the heat as well. So note that. Test using a refractometer, not little bubble testers you use for batteries, not litmus paper to see the acid level, a refractometer. Back when I bought my first refractometer, it was $260. Today on Amazon, I looked it up, $24 I can buy a glycol refractometer for. And it will tell you exactly where you're at. Once you inject it and mix the system, make sure everything's mixed up, then you can test it. Be aware of that. Next, use a glycol pump if you want an autofill. Do not use a water autofill on glycol on a Snowmelt system, because it will screw up your amounts of glycol and freeze that system in a minute. Axiom makes them in all different sizes to satisfy any system. This just happens to be the model that we have in our van for doing our live fire training in Jason's van and Ted's van. So
let me tell you something. Be careful with that, because it got taken out of my van last week because it froze the pump housing inside there.
well, Jason, understand too that you bounce down the road and you do all sorts of crazy shit to that pump. Not like this being inside of a boiler room that's doing snow melt. So we'll just let that ride. Here we go. Tubing layouts. Never run back and forth like you do for radiant heat as shown on the bottom. Always use a reverse return like shown on the top, or use a counterflow spiral where you spiral out around the outside, get to the center, and then come back in between all the loops on the outside. Please do both so you get even snow melt, or you're going to get streaking and people won't be happy. People see pictures of people sitting on their snow melt driveways in their shorts and their t-shirt on a lawn chair, and everything's melted evenly. I found hundreds of pictures of snow melts that were not melting evenly on the internet, and I did not put one in, but instead I put together one that was done in Michigan for you, that's being used off of the Michigan City heat source. Here's the tubing going in on the left-hand side and the walkways. That down the bottom right-hand side is the streets of downtown, and on the top is what they get when it's blowing snow a hellin'. Isn't that cool? So if you want snow melt, folks, do it right and get it done. This is just a lovely job. Anyway, a note about tubing. When you're doing snow melt, you should be using 3/4 inch. We used to say 5/8 and keep your loop lengths below 300. Of course, getting 5/8 today is not so easy that I know of. I haven't seen it in many people's catalogs for a long time. So 3/4 inch is the standard for snow melt. Keep it on 9 to 10 inch centers, 200 to 400 foot loop lengths. But you have to do your finger, right? You have to take your BTU, your GPM, the amount of glycol you have, the temperature it's going to be at, the loop length, and come up with the head factor so you get the right pumps and do it up. I did just recently do a set of steps in a small portion of the entryway of a mansion in 1/2 inch, but my loop lengths were 110 feet. And with that, it was fine. And why did I do that? Because the house was 100% radiant, and we had 200-foot cutoffs of 1/2 inch laying all over Helen Tarnation from the 1,000-foot rolls, and we wanted to use it up, and it was this teeny weeny little area. So it cost me an extra loop or two on the manifold. Ooh, but we saved ourselves the tubing. But you got to design it up front. Must be designed, should be barrierized tubing. Type of boiler. Of course, the first one I suggest that you use an NTI modulating condensing boiler, because we love to condense, right? Your normal water temperature for snow melt's 138 degrees. And normally you run the boiler at 138 and the system with a 35-degree delta T on snow melt, which is why you need a reverse return. So we don't need all the GPM of getting a 10-degree delta T like radiant heat in a house. So, but if you use a condensing boiler, you love to condense. The only thing you don't want to do is freeze it. So you have to protect it from getting freezing water to it. And you have to protect it from getting more than a 70-degree difference, a 70-degree difference between the supply and return. As long as you do those things through your injection, you're good to go. So cast iron boilers, which I've used a ton of in my past, of putting them on snow melt, must be protected. And this requires controls that have sensors that say, no, slow that boiler pump down. Let me get the heat out slowly to the slab so it can be there. Understand that we never want to take a slab from 30 degrees to 135 degrees like that. It will crack and move everything. We want to bring it up slowly. We want to try to preload it. We want to try to get it there so everything grows and shrinks and nothing gets broken. With a cast iron boiler, you can do it with the right controls, or you're going to stretch and grow the cast iron and break that too. I was involved with a lawsuit with my old company. The previous owners had put in not one, not two, not three, but 4 98 series Weil-McLean boilers, because it kept cracking the last 3 sections on it through the Snowmelt because it improperly controlled. I had nothing to do with it. We're going back to the late 70s, early 80s. I just happened to get the paperwork on it, and it got handled by somebody's, oh, that's right, errors and omissions by the engineer. Oops, don't know how that happened. So still looking at the type of boiler. You want to know if you want to do the whole house with a little bit of a snow melt on it, right? If you have a small load for the snow melt, small load for the snow melt, it's great to add it on. You do it through a nice separate heat exchanger so that you can have glycol for the snow melt and water for the house, which makes it nice. But then you start thinking of some of these jobs I've done where I've had 1.5 million BTUs worth of snow melt that in my area here used to run 3 times a year. Now it runs like once a year because we don't get, I've seen snow. I think last season I might have shoveled my driveway twice, right? So why would you put in that big of a boiler for snow melt only? I mean, it's great for large loads, but wouldn't it be great if you could do pool heating too? So I actually have places that have outdoor pools that had heaters, past tense, that we put in this huge metropolis of boiler for the snow melt, put in a tube and shell heat exchanger to feed the pool, and now the boiler actually runs more during the summer to take care of the pool, but it's being used, not getting all rusty and shitty during the unused time, and it's doing a great job and a very efficient job for the pool. So make sure you keep that in mind when you start looking at these.
That's a nice looking pool.
Oh, thanks. It's mine. It's in my backyard. I'm kidding. It's not mine.
How much
So-
snow did you get last year?
What?
How much snow did you get last year?
We got like 3 snows of 3 or 4 inches.
Damn, we had that in the first week.
Whatever. Blah, blah, blah. You live way up in the Pocono Mountains with 800-foot vertical drop.
Ted
Ooh,
probably
big
had
talk.
more than that. Ted had more than me, probably.
I'm going to go back to the pool picture for a minute. There we go. All right, good.
About the
I feel
pool.
better now. All right, so let me make this very clear. Anybody who's on here tonight, the Snowmelt is no place for a 3-way thermostatic control. No place for a 3-way thermostatic control. Do not think it. Do not buy it. Do not put it in. Absolutely horrible. I'm not saying you can't use a 3-way motorized control. I'm saying you can't use a 3-way thermostatic control. Never give a homeowner, because they're going to say, well, can't we get rid of that $1,400 or $2,000 control and just give me an on-off switch? Hell no. The first time he gets that bill after he turned it on and forgot to turn it off for 2 weeks, at 200 to 300 BTUs a square foot, and he's burning up all that stuff, he gets his bill from his local utility and goes, holy crap, you'll wish you have done that.
Well, the other side of that coin is, the snowstorm that comes in unpredicted in the middle of the night, they wake up, they've already got a foot of snow, and they forgot to turn the system on. They never thought to turn it on. It's not going to melt the snow for a while because it's got a huge insulation blanket on top of it now.
Exactly. If you have to go manual control, use a wind-up switch. I know it sounds silly. They're $26 at on anywhere. And if he wants to preload or wants to get anticipatory or wants to turn it on, he can just go over and wing it up, and now you don't have to worry about him turning it off. I've even had people install LED lights on the light switches, on the manual light switches, to remind them to turn it off, and they still haven't turned it off. And they still have gone through a ton of I'm talking about thousands of gallons of oil in my territory that have been burned up just heating up a driveway. So the type of control that's my favorite is the 670 and 671 TechMark control, which is Wi-Fi controlled. You hook that up to an 090, 091 slab sensor that's out in the slab so it can sense the snow in the actual area that it's heating, right? And it's Wi-Fi compatible, so you hook it up to the Wi-Fi, and if your broadcaster at lunch says it's going to start snowing at 6 o'clock tonight, it turns the system on to preload it. And then you start melting snow as soon as it's falling. There's no makeup time. There's no ramp up time. There's no loading time. It's already preloaded to go. You're also counting on the fact that your newscasters are accurate, but you won't have snow. And that's all that matters. You have a nice clean driveway or nice clean walkway. So that's my favorite control. If you use those controls, they do come with sensors. The 670, 671 are capable of handling up to 4 sensors, so you can plug them on and hook them up. This is just a simple injection boiler, injecting the boiler into the system and putting it out there for a condensing boiler. Of course, you can do that with multiple boilers. If you had a cast iron boiler, you see the S5 or the sensor on the left-hand side sensing the temperature going around. You see the sensor going out. And on this, it has a motorized 3-way valve that the controls also handling besides the pumps on either side. This 670 is capable to slow up or speed up your boilers on either side, so it can protect the boiler and protect the snow melt from heating up or cooling down too quickly. And now I'm going to give this one to Ted, because this is Ted's drawing, and Ted can tell us what's going on here.
Well, this is an old drawing, but we've got 2 boilers with multiple loads. So 2 boilers are piped in parallel, so one doesn't compete with the other. They're injecting into a primary loop with close space T's. At that point, we go around. We have an indirect tank with its own pump. So in the summer, those boilers are not trying to heat the entire primary loop. They will only heat that indirect tank. So the primary circulator would not run, just the indirect circuit. And then we've got close space T's off to an air handler. We've got some baseboard zones, which are not close space. They're actually with zone valves. So they're going to run off as the valve opens. They will be flow through there because water wants to take that path. We then have a panel radiator or panel radiators coming off close space T's. And then finally, well, not actually finally, I guess in this case, but there's a Snowmelt system through a heat exchanger. And again, because we've isolated the Snowmelt system with a heat exchanger, we also then have to have an expansion tank and a spiral vent and its own pump and everything out there as well. So understand, the moment you isolate with the heat exchanger, you're basically creating a second system. As far as the Snowmelt system is concerned, the heat exchanger is the boiler in this particular case. And then finally, there's some low temperature injection mixing of 6 radiant zones. So,
Pretty cool system, Ted. And
this is I forget why this was generated originally. It's an old picture I did a long time ago, but this was somebody's system. I don't remember what it was anymore.
But it's a fascinating system to be able to do, to have the boiler pump, the boiler pump's handling the boilers to 2 closely spaced T's, the pump for the primary loop, which is also handling the radiant, and I'm not handling the radiant, but also handling the plate heat exchanger and the 3 baseboard coils.
Right.
This pump would go off using I would assume a 262 Tecmar control at the time. This pump goes off when this pump comes on, so that this doesn't heat up the rest of the house. Too many people in my day were putting the indirect water heaters way down here at the end of this loop, which means this whole loop is hot all the time, which is defeating the purpose. So here we have it right here. So it's the first thing off and the last thing back, so that only this area is getting the heat during the summer. This is just a phenomenal design, Ted. I love this. I saw this and I got so excited. I changed it to a JPEG and blew it up so we could talk about it, you know?
Well, the other thing on this is that you'll notice that anytime you lay out one of these multi-temperature, multi-zone systems, you want to think about what wants the hottest water, what could use the coolest water. So as you go around that primary loop, your temperature is being decreased by each previous load. So of course we've got our own pump for the indirect, so that's getting whatever temperature the boiler is designed to put out for the indirect. But then the air handler gets the hottest temperature, the baseboard gets the next hottest, panel radiator a little less than that because typically they don't need to run as hot. Like you were saying about Snowmelt, they really only need to be looking at 35 or so. So if we're putting 150, let's say, into that heat exchanger, it's no problem getting 135 out to the system. Bear in mind, you never, like you said, 138. At 140, you can stress crack concrete, so you absolutely never want to be above that. And then finally, the low temperature radiant is the last takeoff on the primary loop.
I just wanted to point out too, Ted, something that your return coming from the plate heat exchanger that could be ice effing cold is coming in after the two closely spaced T's
Right.
for the radiant because you used the primary loop pump. You use this pump to be able to supply the plate heat exchanger because you had the right head losses. You got the pressure loss across here because you put those T's so far apart, but you also took away the chance of these two T's getting colder water by being on the hotter side of the loop of the return, which I thought was excellent.
Right. Yeah. That was the idea. Sort of. That definitely was the idea. Was to make sure that that the return from the snowmelt was not affecting anything in the rest of the system.
Fascinating. So
one thing I want to point out as well, we talked about earlier with glycol. Glycol and water will not mix naturally on their own. If you just pump glycol into a system without pre-mixing it, you could have a slug of glycol moving around that system for a year later. It's not going to naturally mix. So if you want to glycol a system, you want to pre-mix it and pump it in that way. Whether it's pumping it in or putting it in the Axiom pump, either way, it wants to be pre-mixed.
That's a good point, because if you pre-mix it, you're not going to introduce air, and glycol will entrain air in the system, especially in a water tube boiler. Fucking loud as hell.
The glycol will entrain air. The glycol actually is it's a necessary evil in this case, but glycol in a hydronic heating system introduces its own set of problems. It decreases the heat transfer efficiency. It increases the viscosity, which makes it harder to pump. And like I said, if you don't pre-mix it, it's not going to mix on its own. So be careful with glycol.
You can also pre-test what you have in your bucket that you're going to pump out of. You can dump, I made a huge mistake. Instead of testing in a system before I mixed, I read the jug, and the jug said it was minus 100, which tells me that it's full strength, right? It's minus 100. So I poured it into the bucket, and I poured 5 gallons in, and because I wanted 20% mix, I put another, I just added, 10 gallon of water and tested it, and I was at like 20 degrees because whatever was in that jug was not minus 100. They cost me the same as minus 100, but it wasn't minus 1. I was pissed as hell. So I went out. I literally dumped that and started over. I mean, there was nothing at that point I could do. I didn't have enough room in a bucket. It was horrible. Anyway.
Well, what I always used to do, I never used an Axiom pump. That's kind of a newer thing for me. But what we used to do is we'd pre-mix everything in a barrel like a trash can, and then we would pump out of the trash can into the system, bring on another hose back from the system, which you drop to the bottom of the barrel. That way you fill the system, but when you don't see any more bubbles coming back, you've properly purged the entire system.
Yeah. People would ask why you have those 2 draw-offs with a valve in between, right? So you could have the supply and return going out and have them separated. And you go, well, that's so I can fill the system. And then you get somebody who calls me up and says, how do I put glycol in the system? And I go, do you have 2 draw-offs with a valve in between? They're like,
That's a good way to get rid of the bubbles. That's a good way to to get rid of those bubbles, Ted, because you'll see them, they'll just migrate right out and they'll get so small.
That's it.
Because
You
if
know,
we-
when you do, and the other thing too with purging a
Good
system,
point.
this is only peripherally what we're talking about tonight. But if you really want to get air out of a system, you have to use a pump that's going to be better than 6 feet per second.
Right.
So it's not necessarily your system pump that you're purging with. You should be using an external pump that can create 6 feet per second or greater is the only thing that's going to drive air out.
Well, I can see those bubbles being very minute at that point coming through that hose.
What's that?
I can see the air bubbles being minute at that point coming through that hose back into the garbage can.
Well, so you suck out of the garbage can, you pump into the system, and you come back to the garbage can with a hose
I
down
like
under the.
that idea. I do. I really like it.
When you see no more bubbles, you've properly purged your system.
I really like
We used to use buckets back in the day when I learned how to purge a system.
it.
We used
Yeah,
buckets.
you weren't using garbage cans. You were
used
using
buckets.
buckets.
The size of the system, you know, in other words, you know, in a small system, obviously you don't need a garbage can. But in a bigger system, you know, you should have a good idea about how many gallons that system's going to take.
Oh yeah.
And you get that pre-mixed ahead of time.
And going back to design, when I used to do designs, not anymore, but when I used to do designs, it would give you the amount of gallons you need of liquid, which would then tell you what you need to have on hand for your premix. And you always want to add about 20% because you're going to spill some. You're going to need some for the axiom pump. You're going to need, so, you know, always allow more for that stuff. So
You need a little bit more too, because you still have to have water in the bottom of the bucket to see bubbles.
Oh yeah. There you go. Wanting to see bubbles. Anyway. So here's a system I designed just recently, and it's actually been used 2 or 3 times now. I did this locally for 100% house or rating house. So here we have 2 NTI boilers going to 2 closely spaced T's. We have a primary loop. We have a primary loop coming off here, right? But notice that I have a T here that goes off to my indirect, like Ted did, coming back, so that only this is working. My magnetic filter is on all the returns.
I love that. That is so nice.
Jason just had an orgasm on the radio. That's good.
That is so nice.
Anyway, then coming off everything, every zone is on closely spaced T's. And I did that for the purposes, I wanted this pump to run all the time there's a heating call and turn off when there's a domestic hot water call. So here we have baseboard, the hottest thing in the house, 3rd floor baseboard in this particular case, 180 degrees coming off first. Second was a set of zones that needed 140 degree supplies going off to the radiant to 5 zones of radiant through a mixing valve. That was a Takeo I valve, 1 inch. Then I used an 1.25 inch mixing valve for the 120 degree radiant zones, of which we had a bunch of. Then I came around, and I should have probably taken this off earlier, but I was more concerned about the cold return, which is why I brought that up about the cold return for you, Ted, because you really solved that problem. But here I have a plate heat exchanger going off to 2 closely spaced T's, again with a circulator, like they all have circulators, going to the plate heat exchanger. My glycol pump comes into here, off it goes for the 2 radiant zones, and then back again to the system. So that was one that I did that I actually solved the problem out in Michigan with. I did this job, was locally here in Bluebell. It's been running for 2 years with awesomeness. I did give the people a manual wind-up bypass switch to override the 671 Tecmar control. And people say, well, why would you do that? Well, it was just for this one pump here on the top, because that was his walkway out to his spa on his back deck. And he wanted to be able to step out of his house and walk across on warm concrete to get into the whirlpool, so that when he got out of the whirlpool, he didn't create an ice sheet from the water dripping off his feet, and it would all be taken care of. But we had 2 choices: either give you another snow sensor, which is going to take hours to make up for that, right? Or a wind-up sensor that when he's going to use the spa tonight, he can wind it up on his way to work. It's going to preload it during the day. He's going to get in and out of his spa. Doesn't have to run anymore because you have all the mass of 6 inches of concrete to be able to walk on. It'll be fine going out there, coming back in. And he was happy as shit. So the people or the homeowners are overjoyed, and just something that we did. So
Yeah, nice one.
thanks, man. So with that, that's all I got.
Thanks for watching the video today. If you'd like to check out more videos, see the link below. Don't forget to like, share, and subscribe to our channel for all the future updates. And also check us out on Facebook, LinkedIn, and Instagram.